1, 2, 1, 2, on m'entend bien? Perfect. Fetra, c'est bon pour toi? Nice. Welcome. Bienvenue pour Montréal Python. MP-121, merci d'être là. Thanks to come here. I tried to switch between English and French, but my English is very bad, so sorry, but I tried. Bienvenue à MP-121. Avant de commencer, j'aime bien savoir qui est là ce soir. So, who are here? For who it's the first time in Montreal Python, la première fois à Montréal Python. Nice, thanks a lot. Welcome for this event. Who speak only English? English, okay. Speak just French, okay. So, bilingual, guys. Ok, donc je peux switcher un peu entre les deux. Parfait. Qui est étudiant? The student. Yes, my guys. Ok, 3 étudiants, bienvenue. C'est très bien, je vous félicite de venir à ces conférences-là. Qui recherche un emploi? Search a job. Ok, nice, some people. Qui a des opportunités d'emploi ou de projet? Ma girl, tu veux nous dire ce que tu cherches potentiellement? Rapide. Maybe a mic to share. Yes, we are professional guys.
Yay, thank you. Hello, everyone. So my name is Eva. I'm currently working on an entrepreneurial project. So it's about impact, social impact, and wellness. So if you want to know more about it, you can come meet me at the end of the conference. And yeah. Exact.
Parfait, merci beaucoup. Donc, n'hésitez pas à aller voir après la conférence. Pendant la pizza, c'est vraiment le bon moment pour parler entre nous. Très bien. Pour les nouvelles personnes, c'est quoi Montréal Python? Donc, Montréal Python, c'est une association qui existe depuis 2009, donc très longtemps, et qui a pour but de regrouper les passionnés de Python à Montréal. So, we are an association to organize some conference, sometimes a workshop, and to create a community in Python in Montréal. On est une association qui vit uniquement sur des sponsors et des dons. Donc, on a des sponsors principaux, notamment Savoir-faire Linux et Python Software Foundation, qui nous soutiennent pour l'organisation des conférences et pour les pizzas. Et un sponsor d'infrastructure qui est FGNR. So, if you want to believe a sponsor, come to see me. Always we search some sponsor to continue the event for this association. And today it's special because it's supported by PyLadies Montreal. It's PyLadies pays the pizza tonight, okay? So thanks PyLadies. Donc c'est ça, l'événement est spécialement organisé par PyLadies. C'est Denis qui est la présidente de PyLadies Montréal qui malheureusement n'est pas là ce soir, mais elle a fait une petite vidéo pour vous. So, pour vous présenter et vous parler un peu de ce qu'est PyLadies. Donc, on va juste prendre 5 minutes pour regarder ça.
Hello everyone, my name is Denny Perez and I'm part of the Python Montreal community, and today I'm representing PyLadies. Thank you so much for being here today at this special Python Montreal meetup. We're really excited about this event because it's all about something that matters a lot to us, that is making our community more inclusive. Before we start, let me quickly introduce PyLadies and what we're doing here as a community in Montreal. About PyLadies. PyLadies is a global community of women who work with or are interested in Python programming. The community was created with the goal of increasing diversity and inclusion in the tech industry by providing an inclusive and safe environment where people can learn, collaborate, and grow together. Although the focus is on supporting women in technology, PyLadies events are open to everyone who believes in building a more inclusive tech community. Objectives de PyLadies. One of the main objectives of PyLadies is to inspire more women to become programmers and support them as they develop their programming skill. This happens through the different type of communities and different type of activities, such as workshop, technical talks, mentoring opportunities, and networking events. Let me explain you about a little bit of the structure. PyLadies is organized as a global network of local chapters. Each chapter operates independently but shares the same mission and values. Local chapters are led by teams of volunteers who dedicate their time to organize events, creating learning opportunities, and supporting the community. This centralized structure allows each chapter to adapt to the needs of this local community, and while this is still being part of a global movement. About some activities of PyLadies. Across the world, PyLadies chapters organize many types of activity, including programming, workshop, networking and mentoring event, technical talks and conferences, collaboration in open source projects. All of these type of activities aim to create communities for learning, sharing knowledge, and building connection within the tech community. About PyLadies Montreal. Here in Montreal, the PyLadies chapter was originally created in 2015. After a few years of inactivity, we were happy to relaunch the community and start organizing events again. Our goal is to continue supporting the same mission as PyLadies globally, is to inspire more women to become programmers and help them to develop their skill in technology. We want PyLadies Montreal to be a space where people can learn, meet each other, and share experiences and grow together. I want to let you this QR code. If you are interested in staying connected in joining future events, we invite you to subscribe to PyLadies Montreal meetup page. You can simply scan this QR code that is displayed in the screen, and we're also always looking for volunteers who would like to help organizing events, support the community, or contribute some ideas. You can scan this QR code to join the team as a volunteer if you want to get involved. I want to say thank you, Python community. Thank you all for being here and supporting PyLadies Montreal by attending this event. And your presence helps us to continue building more inclusive and welcoming Python community. And now, thank you so much again for being here. And let's see you in the next meetup. Bye-bye.
Voilà, c'était Denis qui s'occupe de PyLadies. Donc si vous avez des questions, vous pouvez venir me voir sur PyLadies après la conférence où elle est très active sur LinkedIn. So don't hesitate to contact Denis if you participate in PyLadies or if you have some interrogation. Before to start in conference, I share you this information. Oh, I changed the date, but it's not... OK, don't care. On organise une prévente pour de magnifiques t-shirts. je fais des casquettes et aussi des sweatshirts. On voulait la fermer ce soir, mais finalement, on va laisser un mois supplémentaire pour pouvoir acquérir ces goodies Python Montréal. L'idée, c'est que ça permet de soutenir l'association en ayant un petit souvenir de Montréal-Python. Donc finalement, ça va se fermer au 16 avril et les éléments les achats seront distribués lors du dernier Montréal-Python qui sera au mois de mai. So if you want some thing for Montréal-Python, you can buy some t-shirts, caskets and stickers. So il y aura des QR codes près de la pizza si vous voulez prendre vos goodies après la conférence. Mais lançons-nous. So the first speaker, it's Michell Payano. She come and she talk about what's new in forecasting. So please welcome to Michell. Ta petite transition, puis on va commencer.
Okay. Perfect. I think everyone can hear me. Okay, amazing. Well,
Okay, let's go.
Thank you so much.
And it's what?
Okay, amazing. Thank you. Okay, so today I'm just going to be giving you a brief talk about what's new in forecasting. I found it very interesting since I think it's a subject that any of you, either you're a student or working right now, it could be useful. So just to give a very brief and dumb introduction, what is forecasting? And we know that forecasting just is basically the process of predicting future values. We have a given sequence. This is the case where we have many values and we would like to predict some values in the future. In this case, it's univariate prediction because we are only using one variable. But what is interesting about forecasting? It can be useful to monitor market volatility or risks. We can use also for weather, for example, like meteorological predictions and climate modeling. We can use it even for neurological signal mapping and many other teams, like for anyone that is working on computer systems and want to predict like any kind of failure or luck. But things get more interesting, start to get interesting now with the use of foundation models. And basically, foundation models, they are trained with vast amounts of data. Like for example, right now, since 2017, we have seen like this increase of use of foundational models because now we have models, things mostly of the foundational models, they have the base architecture, that is the transformers. I don't know if you have heard about them. So basically they are, like I said, trained. We have different kinds of data. We have text, we have images, we have a speech, we have extracted data like tables, etc. We have 3D signals. We have many kinds of types of data. And then we decide to train a model of any kind of architecture. And this model that is trained with these immense data sets can fulfill a broad range of general tasks. Like, for example, they serve as a base of building blocks for crafting more specialized applications. Like we can use a model that is trained with these vast amounts of data for question answering, for sentiment analysis, information extraction, image generation, image captioning, many other things. And just I'm not going to show you math, any kind of math today, but when we talk about foundation models, and maybe it's something that it would be easy for you to understand what I'm talking about. Like we have GPT-4, we have Meta, we have Llama that is made by Meta. We have Palm 2 by Google, and we have Claude. This is just a few examples. Like we have many others that we can use. These models are most of the use kind of in our daily basis because we can use them for many things, like asking anything that we would like any question, like how is winter in Montreal? A general question, or maybe it could be used for coding. Especially used among students, but also researchers. But what I want to make you understand from these presentations is how we can make the connection between foundational models and how we can use them to make predictions. Because, for example, if we have a time series data set, I don't think it will be the smartest thing to send that data set to GPT-4 and please make a prediction for the next 7 days, you know? However, what I want you to grasp from here is that the main architecture can be useful in order to transform to a model that can be useful to make predictions. So in this case, I'm gonna show you, I think this could be very useful for you to look at this paper. It's called Llama. So the idea for this paper, or the researchers, that what they did is that they used the architecture of Llama and tried to apply it in order to make predictions using univariate time series. Basically, they pre-trained this large corpus with diverse time series from several domains. For example, what they specified is that they use 27 data sets, but these 27 data sets, they are domain diverse, like energy, transportation, economics, etc. So at the end, it's like, even though 27 data sets sounds very small, it's not kind of small, because at the end, these data sets of different domains, basically, contains more than several thousand different univariate time series. So what they tried to do was a way to come up with a model, and this is not the only model that is trying to use the foundational models architecture and make it useful for time series. There are also other companies that have been working on that, like Amazon, but I'm just wanted to use this kind of architecture because they have a good repo and also a good paper that I think it would be very interested even for you to replicate, but yeah. And basically they have 352 million training windows, which means tokens. So at the end, I would like to show you, like, if you want, I will recommend also just for you to scan this QR code, because it's gonna give you the Google Colab that I'm gonna show you. I'm just gonna go step by step to this Google Colab, but however, I wanted you to have it. So, okay, I'm gonna stop sharing for a moment in order to make the switch. Yes. Window. So. Okay, so this is the Google Colab that I'm gonna show you step by step, guide you step by step of what we are doing here. I hope that is, no?
See the great thing. Maybe we share you full screen.
Okay. Let me see.
Exactly.
Sure.
Perfect.
Okay, amazing. So yeah, we're gonna do basically two things. We're gonna do, while I'm guiding you through this notebook, I really recommend you to do, I think it's here that we save a copy in your drive, if any of you want to save it in your computer and to run it later on. The good thing about this model is that It's not that big amongst transformers architecture, so it can be run either with GPU or CPUs. Of course, it's more recommendable to run it with GPUs. But the thing is that we're going to try two things, just to confirm what the authors of the papers claim that is useful for make predictions, even on data sets that it haven't been trained on. That's why we are gonna test the zero-shot capabilities. That's why that's a term that it uses, zero-shot, when we want to we use a model to make inference, even on data sets that it haven't been trained on. And then we are gonna fine-tune to see how good it is with our own data set. So just very basic, we are gonna clone the GitHub repo, which I think that it will be very useful to see a step-by-step all the scripts that they have in the repo. And when we download the weights of the pre-trained model, is the weights are saved in Hugging Face. And now we're gonna use this data set. It's just a plain old data set that is just about daily minimum temperatures. It's very old, so a few decades old. And what we are seeing here is something very similar, something that we can even infer from Montreal weather, where we have winter, we have a spring, we have summer, autumn, etc. So that's why we see seasonalities. And what we would like to infer from this, using this model, is to see that if it is capable to predict exactly, or if it is capable to detect the seasonalities that we are in. So here I'm just making kind of some data pre-processing. It's very simple what I'm doing right now. And furthermore, something that we will use later on is that we are splitting something basic that we do in machine learning, that is splitting the data into training, validation, and test set, because we are going to use later on to fine-tune our model. So let's try zero shot, something that I was telling you about, and something that is even suggested in the repo of the authors of the paper. Like, first try to evaluate if this model is good enough or not before fine-tuning it. So what we're going to do is something that, since our data is daily, we will try to predict 1 week out. And we will give a context to this model, because since I wanted to skip the architecture or the math behind the model, there are some hyperparameters important to keep into consideration in order to make our predictions. So the context length would be the lags to use as context. In this case, these are numbers that we can play around. So I wanted to, like, everything that I have here, I would like you to modify it for yourselves to see how different results you can get from this. Okay, so many basic things about, like, we already downloaded the pre-trained weights. We are gonna use the same, basically, model architecture hyperparameters that the authors use. And here is basically our backbone. We have many hyperparameters. Like I said, we have the prediction length, what we want to predict. We could basically say that instead of predict the next 7 days, we can predict the next day, or next 2 dates, or even predict, with the information that we have right now, let's predict how it's gonna be the temperature in the next 30 days. That's something that we play a lot. Other things about the transformer architecture, maybe that's something that could be useful for the next Python Montreal session, if it hasn't been done yet, in order to code from scratch a transformer architecture. But yeah, just things that go step by step. And now we are gonna do our forecasting. So, like I said, instead of predicting a single point, like predicting the temperature for tomorrow, we are going to evaluate our model to predict across different starting dates spaced in 30 days apart. We are doing this? Remember, I don't know if you remember when I said a few minutes ago that we are dealing with the weather data, okay? So in the weather data, we see many seasonalities and behaviors and waves, because when it's winter and then it's summer, like how the temperatures move across the year. So just to kind of wrap up and don't bore you too much, what I'm going to show you is how the models makes the prediction. But another important metric that I want you to keep into consideration is that in order to assess how good the model is, we have to keep in mind, well, we have to keep in stock, we have to make a comparison of the prediction and the real values that are actually in our data sets. And we are going to use what is called the mean absolute percentage error. So basically what it's going to tell us is that, for example, mean absolute percentage error of 5%, which is really good, means the forecast was off by 5% of the true temperature, okay? So after we do this, we can see, okay, let's see how good is this foundational model, how this foundational model claims to be. And we have 9 examples. And these 9 examples, like I said, that they contain like 60 days. Basically, we divided our data set in 60 days. And we are seeing how the blue line is the real time series. And the green line is the prediction of that models for the next 7 days. However, when we see the darkest green line, but we also see like a shade of darker green and lighter green. It means it's try to make an interval of how confident this model is. So we are looking at, okay, predictions are not perfect. We have phases on time where our model is not good at all because it's the error, the MAPE error is above 50%. So it's way worse than a random guessing. However, there are some parts in time where the error is not that bad, like 30% or around 14% of MAPE. So this is something that when we are doing forecasting, we are normally training a model specifically for each time series. However, when we use foundation models, the thing is that how can we use a model that can generalize or can be able to be useful for data sets that it hasn't been trained before? So, okay, we already measured the zero-shot capabilities. We are not that satisfied. But of course, my claim from this is not that the model is good or not, because this is a very simple data set. But what I want to show you is that how we are able even to use a model that was trained with other very different data sets, how it can be used for our own data. So another second step that we can do is fine-tuning with these data sets. I was telling you before, in the examples in the presentation, I think that I can, yes, okay. I was showing you here many foundational models that we use every day, like ChatGPT, Claude, etc. And even these kind of models, it's possible to fine-tune for our specific data sets, but that's another kind of process in order to avoid what we call hallucinations. In this case, since we are not dealing with text data, we are dealing with a specific kind of data set that is only time series and only varied time series. We don't have what they call hallucinations. However, we can fine-tuning in order to make it better, in order to adapt to our own data sets. So something that, like I was explaining you before, I was telling you that we have many hyperparameters. Imagine hyperparameters like, in order for the ones that don't understand what is a hyperparameter, when you buy a new phone, you have some kind of settings. And what we are doing is modifying those settings in order to our like. Like, for example, if your phone comes with a specific ringtone and you don't like it, you change the ringtone. So basically, that's what we are doing right now. And I would like you also, I leave this space here, like things to experiment with. Like we have the context length, we have the learning rate, we have the max epochs. Those are things that are going to help our model to learn. either faster or slower. But we have like a kind of a trade-off, because if we allow the context like that's for example, how much steps in the past is gonna our model is gonna see. It could increase the capacity of our model, but maybe it could take longer to train. And like I said, in the notebook, you can also select if you would like to use GPUs or CPUs. So I use some kind of default settings, like for example, I would suggest you to change all these things. For me, it took me like around 40 minutes in order to fine tune this, but very simple and in a very small data set as the one that I'm presenting to you. So I will also recommend to play around with other kind of sets that you have. And when I wanted to evaluate and see, okay, if I adapt this model, maybe it's gonna behave better than when it did previously. Actually, it didn't. But that's why this could bring it to the discussion. For example, I'm gonna move around a little bit fast, just for the time. Just for you to see, for the ones that don't have the notebook, if you see in the first three plots, we have an error around 30%, 70%, and 14%. And after fine-tuning, it got worse, actually. So does that mean that fine-tuning is not a good methodology, or is a good approach? Not necessarily. Because like I said, in order to increase or make our model learn better, we will have to play around with these features. But in order, for the sake of time, I just use very simple features. And yeah, so my takeaway from this is, I wanted to show you how these architectures can be nowadays used for many subjects, not only C foundation models to be used for natural language processing or for image generation, as many other models that we have seen in the internet. But we can also use these architectures to have to help us make predictions that maybe, even though it was not that useful in this kind of data set because of the behavior that it shows, like weather data, but maybe since this model was was trained with economic data sets, maybe it could be, let's imagine, as the authors of the paper said, I will show you quickly in the paper, the data sets that they use in order to train the model. Like we have, for example, we have economic data even from, I think it's Beijing, if I'm correct. Yeah, but here you can see more about the statistics of the data set that they use. Okay, maybe, oh no, it was air quality. Maybe if they use a data set to predict the air quality in a city like Beijing, is it possible to predict the air quality for a city like Montreal or things like that? So, well, that's my presentation, and thank you very much.
Thanks a lot. Some question here? Yes.
I have a question around which type of model, like what is the best model to use? I don't know if you ever use Prophet. Like what is the difference? When should I use Prophet or this one?
Actually, thank you for the question. That's a very good question. The thing is, it's very hard to decide which kind of model to use. Basically, the best answer is just try it. Because these models have different architectures. They have been trained on different data sets. And yeah, so it will depend always on the use case. That's my answer.
Thanks. Another question? No. Okay. No online? No. Okay. So thanks a lot.
Thank you.
So we switch some presentators, Stefania. So Stefania, Pecore talk about switching your model to play fair. Fitras, tu vois son écran? Perfect.
Okay. So, before starting, have you ever measured fairness, ethical AI? Have you ever done this before? Nice. Okay. But which is better? It means that we can all learn. That's nice. Okay. So, why it's interesting to do it? So I will just say one thing because usually people will ask me this. So I will just reply right now. Do we use it in production? Usually not. Okay, I will just reply to this question. Unless you are a very specialized company whose reputation is based on ethical AI, then they will use it in production in a continuous way. However, as a data scientist, we will use it, and also sometimes data analyst, we will use it to understand the data and to suggest how to make sure that we can improve the model over time, or how we can monitor the model over time once it is in production. Okay, so now we are going to use in particular two packages that are called Fairlearn and Equitas. And we are going also to use one dataset that is called the adult income dataset from, if I remember correctly, is the University of Chicago. Just to give you an idea what is the dataset look like. So it's basically, it's not a super big dataset, but however, it has enough data to play with. Where you have basically is how to describe the people in the United States is a very old data set. I think it's in the 90s. So it's not a data set from today. So the data that we are observing is not from today. But as you can see, we have the age, we have the work class. This one, we are going to drop it because it's just a weight that they use to basically measure the different people, the different categories of people inside the data set, the education, marital status, occupation, and so on. So is I think in English it is also called census. It's a description of the population. Okay. So first thing first, after that we have, of course, installed all the packages, we are going to basically retrieve our data set, and we are going to divide it in an object that is usually object of a data set. So the idea here is that we want to study the income of people, and we want to try to predict that income. So the income threshold is 50K. So how many people will gain more than 50K and less? And we want to study that looking at the gender, or in this case, at the sex. So what we are going to do is we will take all the data set except for one feature, which is the sex, because we want to separate and study it. So first thing first, I will just, so can you notice if there is a problem with this dataset in general? Yes, we have a problem of distribution, so we already start in a very bad way, but we cannot change for this experiment. Usually what you will do is if you are a good person, you will not use the data set as is. If you are a bad person, you cannot do anything else well. You will use at least fairlearn to understand that there are consequences. Okay, so what we are going to do here is basically, in this case, we are basically trying to say who are the people gaining more than 50K, who are the people who are gaining less than 50K. They will be in a binary class, so 1 and 0. Nothing extraordinary. Okay, so here I'm just trying to inspect in one row, but you saw how the data set look like. So for this experiment, I'm going to use two different models. One is the decision tree, and the other is a normal regression. I will explain after why I'm changing the model. Why I'm choosing the decision tree is because it's one of the most interpretable models that we have. So I decided to start with the first one that is at least the most explainable one. You will have all the notes on this collab with further explanation. I didn't use stratify, but usually you will use it just to maintain the distribution of the two classes when you are in production. So once we have this beautiful decision tree, we see that the overall accuracy is not so bad, 85%. We are happy. The question is, are we happy? So when we look we will introduce this first new package that is the metric frame, which is from fairlearn, and it will compute every metric for each subgroup. So metrics for sex, female and male. And basically, when we do this, we are going to see that there is some problem on the data. So basically, when we see the results, the overall accuracy is good. But when we look then at the basically at the results for the selection rate and the other metrics, we see that the accuracy that we see is misleading because we have a class imbalance. So basically, every time, like not every time, but we have many women that are classified as women that are gaining less than 50K, which is something that the model will learn because it will see it often in the data set. But again, we have a class imbalance, so it's not really reading all the people that are in the population that we are observing. So it will try to predict the most seen class. This means also that we will have a feeble number of women that are selected with a salary that is higher than 50K. And if we look at the FNR, so the false negative, more than half of high-earning women are missed. So this means that if you are earning more than 50K, you are not seen. So when we look at this in this way, it's just a data set, and we are just looking at some data. The problem is that when you base this, for example, to see if someone in front of you wants to, can ask for a loan or not. At that point, you will automatically say, no, this person is not the right one. We cannot do it. And unfortunately, for experience, I can say that this happens. It's something that we have in any bank out there, also here in Canada. So that's why, however, it's important to study this kind of stuff. Okay, so, oh yeah, I forgot that I did also a beautiful graphic here, just to show the false negative rate. so they miss high earners, and the selection rate. So basically, what happened next is that what we want to do is trying to understand with another package. This one is developed by the University of Chicago. How the two classes, not only the distribution of what we are seeing, but also how class A is compared to class B. Especially because I think also as humans, we understand better how things work if we compare two objects. So basically, we are going to measure what it is called disparity, which is basically a comparison between two classes. And what we would like to see if that we have a number at the end that is more or less near the 1. If we don't have that number, if we are not near 1, it means that there is a large disparity. Okay, so using this Equitas package, we are going basically to audit our data frame and our model. And we are going to measure this disparity attribute. So, and of course, we are going to measure for the feature of the attribute, in this case, sex, and the attribute female and male. So what we are going to see is that basically women receive the positive prediction only 14% of rate of men. So again, we see that there is the disparity here. And the high earning status women is missed 18% more often than men. So again, we are not really see something that is so extraordinary. We see that there was a bias, but now we are seeing between the two classes. So I will let you read all the explanation. I try to explain every single stuff that is happening behind the scenes. Now, what we can do, and now it's this is the most interesting part. There is something that is kind of, how can I say, annoying. We cannot change bias in the society, and when we measure bias, or in this case, disparity, we can try to post-correct after we train a model, but we are going to have more errors. Why? Because we are observing that there is a class in particular with the data that we have that is not handled correctly most of the time. So we want to make sure that the model will be more gentle with that class, I would say. To do this, it will be a little harsher, or it will be a little confused to the other class. So we are going to improve one class, and we are going to have some repercussion in the other class. We are not losing all the accuracy that we have seen, but however, we are going to lose some accuracy, which is also the reason why sometimes, also when we see some disparities, it's hard to correct them. But of course, we all learn here that the best thing is, first of all, to have a balanced data set, if possible. So here we use another part of the FairLearn package, that is the threshold optimizer. We are going to optimize after we train the model for basically the demography. So we want to make sure that the class of women and class of men will be optimized compared to what we have seen in the base model. But we are basically doing after, so we are not retraining. We are just modifying how the model is trying to set the threshold that can let you say, okay, this goes into the class of high earner, this goes into the class of low earner. Okay, so in this case, I'm using, I'm not using anymore the decision tree. I'm using a regression here. You can use also the decision tree, but you have to have a big data set, because you have to have more in-depth division. So if I do it with this data set, we will not have enough data then to analyze it. Okay, so basically here, what it's doing is, okay, here we are just calculating the model. We have a similar accuracy, so 85% as before. And here, as you can see, when I build the threshold, I'm really using as a constraint the demographic parity. And of course, I'm looking at the accuracy. So what happens after is that at the very beginning, we had 85% of accuracy, and we have now, after this threshold optimizer, 83, which is not dramatic. But however, we have a decrease in accuracy. And it was basically what I was saying before. The reason why we have this is that we want to balance in a post-processing way the data and the result. So we are basically simulating what we want to see. Again, I will suggest you, when we have time, to explore the Fairlearn package, because there are also other methods. It depends on the data and depends on what is the attribute that you are looking at. But I will say, in any case, you have always to balance what you have as a result that will be always a little less accurate than what you had at the very beginning. But we also see that the accuracy, the very high accuracy that we had, was misleading. We were just being very accurate in only one side of the story. I don't remember if I've done any other things. Yes. So, yeah, I did a comparison. So in the base model, with the logistic regression applied, we see that, however, we have a difference in the accuracy, such as basically we have a disparity within female and male, but especially it is important to see the selection rate that is very low for the female part and is fairly high for the male part. When we apply the threshold optimizer, we see that the selection rate in this case will be very near, not identical, but very near. So if we do an analysis in general of the results, we see that we have a trade-off where we have improved the female representation. Is not the super highest that we see, but the one who paid was the other class. Now, there is a question that we can ask ourselves, is this fair? Because however, we are in some way modifying also the other class. And I cannot reply to this question because there is not really a reply. I will say it depends really on the product that you are building. Of course, it's very hard every time to reply to this question because it's like to defining also what is ethical and what is not. There are some things that are very hard to say it's totally ethical, it is not. What else I've done? Okay. Oh yeah, other graphic, very beautiful that you can see. I should have put the graphics before, but it's okay. Other thing that you can do, and I will leave with that, is what happened when, like here we were basically see, am I supposed to move? Can I move? I didn't ask this. Oh, I hope I can, I will say, sorry. So here we studied only the sex attribute, but you can also do what we call the intersectional study of attributes. So instead of studying only one attribute, we study more attributes at the same time. Why it is important? Because the other challenge that usually we have is with the race. And it is important, for example, if you work in any software about hiring people, you need to understand that there are some biases. So, and these biases will accumulate once you have a sensitive attribute such as sex and gender. So it is something that you can do. And again, the good part of these, honestly, of these packages, and I think it's the most important thing that I will say today, is that before they were existent, you had to manually code everything. In this case, basically, you have to do some lines, and that's it. It's already done for you. So I apply the same, this case, for gender, for sex and race. And what I notice is that if you see, in terms of selection rate, we have a huge disparity when we talk about female Black. If we compare with, for example, male Asian class. And again, here we are just looking at number, but in the reality, then you have ATS software, you have bank account, and many other stuff, also immigration. Okay, I think it's over. Yes, there are the broader ethical considerations that you can read when you are at home. Yes, 5 minutes, but I finished, so now I can collect questions, if there are questions, of course. I hope it was not so. Thank you. It's my first time presenting this kind of workshop.
Some question? Yes. Perfect.
We are asking each other questions. Yes. Women's solidarity.
Thank you so much for the presentation. On your experience, you already gave us a good technique to change the threshold of the models in order to kind of fix a little bit the bias. But what do you think about data augmentation techniques? I also heard that there is a trade-off with this, but do you think that is useful?
Data augmentation?
Yeah.
Okay. Yes and no, in the sense of the problem with data augmentation, especially when you talk about synthetic data, you are just replicating a pattern. So you are not sure that the pattern that you are replicating is not showing biases. So you should be able to debias your data augmentation, your data augmented data set in this case. The best will be to have even more data and try not to do like a general data, like a general analysis of everything. We should be able to understand that there are some differences that we have to calibrate. But it replies also, like, it means that we have to understand society too. We got the philosophical question. Okay.
Another question? Soyez pas timide. Ah, perfect.
I'm sorry, I'm still keep moving.
Is it even good to reduce the, for example, false negative rates for female when they have very small sample sets? So, like say 5% increase in decrease in false negative rate, and we have 4% increase in false negative rate for males.
Mm-hmm.
Well, they are double the number in your data set. So, actually,
yes, like
it's not very good even.
Does it work to just readjust classes when we still not have optimal results, basically? It's very hard to reply to this question. I will
something else before you reply.
Yeah.
Yes. Did you make the $50,000 at a categorical value, or is it some more variance? So, for example, if we predicted 49,000 is the income for that person, and we might increase the deduct is over 50. We are not very wrong. So.
Yeah. So honestly, in a real model, I will not even just have two classes like high and low, because it's
more
yeah.
fast.
Yeah. So for sure, the problem is, like, even if it is only $1, no matter in which type of class you are, if it is not correctly classified, you are going to lose something. To the first question, does it worth it? There is no reply again. What I will reply in real life, however, is it depends on the product that you are building. If, of course, there is any, like, let's suppose your target is mostly like female, okay? In that case, you will need for sure to analyze your data set to make sure that at least you are using a good data set for what you're building. Yes.
Perfect.
So first, thank you for the presentation. It was really great. My question is less technical and more on the communication side of things. So in your experience, what have been the main challenge to communicate bias? Because it's a very complex topic.
Oh, yeah.
And as you mentioned, like, if we correct for one group, then we're harming the rest of the data set. There's a lot of nuance, and also data represent the past. Is not, yes, it's predictive of the future, but we know to which extent. We don't know to which extent, that's the point. So how do you communicate all those nuances on such a sensitive and complex topic?
Very good question. And it makes me laugh because today I had some similar questions that have been asked. So it depends, of course, where I am, who is the person I'm talking to. And yeah, basically I can reply exactly the same. That's interesting. I like that this question is ongoing because it means that we are talking even more about these topics. So I usually, what I will do is, if I'm talking with a person that has a genuine interest and is trying basically to understand how things work, like in the case of this morning, I was just being asked, how can you explain biases in generative AI? And I'm like, okay, if it is just a normal user, so they are not technical, they're not interested. I will just say that basically they are using some tools that they think they are super smart, but they are just numbers. And what I will try to do is not only tell this, but just showing them. So I will just make sure that they can see with their eyes that it's really easy to make them do things that are totally out of the world. And so one of the examples that I usually do, for example, is generation of video. If I change some words or if I change also the language, I will have some results that are, I never said that I wanted that kind of character doing that kind of stuff. And I'm like, this seems only a game, but when you have marketing teams that are basically creating advertising and you are continually watching this, at some point you are basically feeding yourself of this kind of images. And you are basically recreating them after while you are using AI. When I talk with businesses, it depends. So as I said also this morning, sometimes I refuse to work with them directly. I just cut the problem. It's like, okay, bye. Otherwise, one thing that works very well is, again, since ethics is something very hard also for me to explain, is the best thing that you can do is to try to do analogies and example for the consequences. Because these are the things that you can understand, you can almost touch every day. So for the businesses, will be reputation damage, will be income loss, it will be, I don't know. Yeah, basically these are the two arguments because they want to do money, they don't want to lose money. But I will say also with businesses that are a little more light when you need to convince them. It's also, are you sure that you want to use this kind of data that can basically give you as a result something that is not representing you really? Is this the representation that you want of yourself to the world? Usually that works, not 100% of the time, but we are all different, which is also why we have a hard time with ethics. I hope it replies to your question.
Thanks. Another question? No? So thanks, Stefania.
Thank you.
Just switch.
Thanks a lot for presentation. Encore quelques minutes avant le moment avant la pizza. Nos prochains événements, si vous voulez revenir passer la soirée avec nous, les 2 prochains événements, donc il y aura lieu le 16 avril et le 14 mai. Et il y a aussi d'autres événements qu'on aime bien mettre en avant, dont Rencontre Linux, Linux Rencontre Linux ou Linux Rencontre Linux, je l'ai bien dit cette fois, qui est le 6 avril et qui se passe à l'ETS. Et 3W Québec, je pense que Benoît n'est pas là ce soir, mais si vous voulez chercher sur LinkedIn, vous allez trouver les informations pour trouver. Puis c'est des groupes aussi un peu différents, mais qui parlent de sujets Linux plus très centré autour de tout ce qui est Linux. Et 3 Québec, c'est un peu plus large. Donc je vous invite à aller. Et sinon, vous pouvez retrouver nos événements à nous sur Meetup. Il va y avoir la pizza. Je vous rappelle qu'on a la prévente des t-shirts. Vous pouvez avoir nos t-shirts. Il y a des QR codes qui seront présents si vous voulez. Et il y a aussi un QR code pour donner votre avis. Si vous voulez donner un feedback aux conférenciers, vous pouvez scanner le QR code et remplir le formulaire. Et la dernière chose que je vous demandais, c'est si vous le souhaitez, venir ici sur le stage pour qu'on fasse une grande photo pour l'envoyer à Denis qui n'est pas là ce soir. Donc, si vous voulez bien montrer que la communauté Python Montréal est présente, so if you want about, si vous voulez être sur la photo, vous pouvez venir ici. Merci. La présente, c'est ça. Bien sûr, les conférencières sont obligées d'être sur la photo. Il y en a qui peuvent être dessus. Je ne peux pas faire ça avec ma jambe pour le moment. On va organiser ça. On peut avoir différents niveaux. Est-ce qu'on... Oui, allez-y, vous pouvez, allez-y. Ah, parfait. Je ne vais pas donner ma caméra parce que j'ai un peu compliqué, mais c'est bon, ça va bien? Ah, parfait. Très bien. On en fait une sérieuse.
Je parle des photos tout le temps.
Ok, et moi on dit merci beaucoup. Merci. Yes, I've started 50 years. I can.
Yeah, I wish I had bought Canon originally because I bought Nikon, but they're more expensive.
When I started the same place, first the world Canon like and afterwards buy just
Yeah, here it's more Spanish. I mean, it's a mix, but it is more Canada.
Yes, it is.
Yeah, pretty much the same thing.
Yes.
So it's like,